Hello friends, today we are going to learn about mixtures and types of mixtures. As the lesson starts, we see about that pictures of a pure ghee, pure milk. So what is pure? We will know. So what is pure? Pure, pure as the normal people think. Pure means it does not contain of any other chemicals and no adulteration in it. But according to scientists, the pure substance means which contain or constitute particles of the substances are in the same chemical nature. And this is about pure substances. And now we are going to talk about mixture. So what is a mixture? Mixture are constituted by more than one kind of pure. But means it does not have any one kind. More than one kind is known as mixture. So as we see there are many kinds like ghee. If we take the example as ghee, it contains of many carbohydrates, proteins, vitamins, etc. and etc. As you all know more about me about this. And next we are going to talk about types of mixture. As we come to know about the types of mixture, in types of mixture we see about heterogeneous mixture and homogeneous mixture. In the homogeneous mixture we see that, let us take an example of the sugar and the water. As we as we put the sugar into the water, it stays well and it becomes, and as we see that it becomes solute, means it dissolves in the water. As it is dissolved in the water, we can see that we cannot separate the sugar from water. But when we take the example of a chalk powder, when you put into the water, the chalk powder does not mixes with the water, and we can see after after some time of stirring that it will stay in the bottom of the water. As it stays in the bottom of the water, we can say that it is a heterogeneous mixture. So as it is a heterogeneous mixture, it does not get dissolved in the water. But in the homogeneous mixture where we took as a sugar as our example, we can see that it is totally dissolved in the water. Most of the students get confused between what is homogeneous and what is heterogeneous. So I thought that this may help them. So let us recap it. What is homogeneous and heterogeneous? In homogeneous, it dissolves completely, equally, and we cannot see through our naked eyes that difference between them and even in the microscope. But when we took the example of a chalk powder, it makes the difference after stirring after some time it stays in the bottom of the glass or water where you put it. So now you got what is a homogeneous mixture and what is a heterogeneous mixture. And now I'll show you the activity which may help you to understand it better.
4 beakers potassium permanganate and copper sulfate, wheat flour, milk, spatulas, a filter paper, 4 conical flasks and water. Label the 4 beakers as A, B, C and D. Fill all the beakers up to the 100 ml mark. Put few grains of copper sulfate in the beaker A. Put a full spatula of copper sulfate in the beaker B. Put a spoon of wheat flour in the beaker C. And put 2 teaspoons of milk in the beaker D. Thoroughly stir all the liquids in all the beakers. Prepare 4 conical flasks with each one having a filter paper. Pour each of the mixture throughout a filter paper covered conical flask. You will notice all the liquid has seeded into the beakers A and B and nothing is left on the paper. This type of combination is called as a solution. The flow from the beaker C is filtered out in the conical flask, and when the flour was with the water, it did not combine with it. The particles were dispersed in the water. This type of mixture is called as a suspension. Notice that the particles got separated even before the pouring through the filter. In the mixture D, you will notice that there is nothing in the filter paper. This is a colloidal solution and we will study the properties in the subsequent sections.
We see the activity
Types of mixtures.
2.2.
We will start this section with an activity. For this activity, we need 4 beakers, potassium permanganate and sodium chloride, spatulas and water. Label the 4 beakers as A, B, C and D. Fill all the beakers up to the 100 ml mark. Put 1 full spatula of potassium permanganate in the beaker A. Put 2 full spatulas of potassium permanganate in the beaker B. Put 2 different ratios of potassium permanganate and salt in the beakers C and D. Truly, stir all the liquids in all the beakers. You will notice that the color of the mixture in the beaker A is less dense than that of a mixture in beaker B. Even though these colors are different from each other, in the individual beakers, the potassium permanganate is distributed evenly and hence they are called as homogeneous mixtures. The mixture in the beakers C and D contain different components of potassium permanganate and salt, and their color varies throughout the mixture and hence they are called as heterogeneous mixtures.
Now we are going to learn about suspension. So as we start about our topic as suspension is a non-homogeneous systems. As we saw in activity 2.2 before, so in which there was dispersion. As you saw that surface was not dissolving with the water. After some time it would settle down. So they were dispersed in a liquid or called suspension. That was called as suspension. A suspension is a heterogeneous mixture. If it is a non-homogeneous, then it is a heterogeneous. So now we are going to learn about properties of suspension. So the first point, which is suspension is a heterogeneous mixture. Yes, it is a heterogeneous mixture because it settles down. As we see a boundary of water and a surface, the water does not say that, oh, I don't want to sit in the same glass where the surface is there. It does not say. So it is a mixture. So guys, now let us go to the second topic, which is the particles of a suspension can be seen through our naked eyes. Yes, we can see them through our naked eyes because it appears. So now let us go to the third topic, which is the particles of suspension scatter a beam of light passing through its, and its path is visible. Yes, its path is visible because it scatter light. Now you don't know much about this because you will learn this in the next topic, which is the convergent solutions. So now let us go to the fourth point, which is the solute particle settle down. Yes, as it settles down, we can see that. As we take the example of a cupcake, we could see that. And when a suspension is left undistributed, that is, a suspension is unstable. Yes, the suspension is unstable because they are mixed unequally, because they, as you can see that the cupcakes and the water does not mix with each other, and we can see them, and it is undistributed. So they can be separated from the mixture by the process of filtration. Yes, when you the step of a filtration, this could be separated. Then when particles settle down, suspension breaks the suspension. So when it settles down, it does not scatter any light. You could check this in your homes or anywhere where you could do this activity. So this was about properties of suspension. Now let's go to the video and see and learn more about it. Guys, now we will learn more about suspension as we show in the next video. So guys, thank you, and I think that this may help you, and I think you have understood.